So first of all, I want you to classify this triangle. I want you to tell me, what it looks like. Of course, we have to have measurements to be sure, right? And then we're going to talk about their angle measures and their side measures and decide how they work. So first of all, what does this triangle appear to be? Obtuse. It appears to be obtuse, right? It looks like the angle A is more than 90 degrees, okay? So that classified it by angles. Now let's classify it by sides. Does it appear to be scalene or equilateral or isosceles? Scalene. It appears to be scalene. So let's put some numbers to it to make sure, okay? So are you right? Is it scalene? Absolutely. Okay, so what I want you to do next then is I want you to tell me the sides in order from the smallest to the largest. So what's the smallest side, Jessa? AB. So AB is our smallest side. Okay, segment AB is our baby bear. Okay, Matthew, what is our medium-sized side? AC. AC has a measure of 6.6, so it is definitely the middle side for mama bear. Okay, and Aubriana, what's our largest side? CB. So we have them in order from smallest to largest. Okay, now let's look and see what happens with the angles. Okay, so again, we want to list our angles now from smallest to largest. So Chris, what's the smallest angle here? Angle C. Okay, so I'm going to write it next to my smallest side. Okay, and Cora, what's our middle sized angle? A looks like it's our obtuse angle. So what's our middle size angle? Which one's the middle number of these three? Yep, B with 40 degrees. Okay, and Josh, what's our largest angle? 119.5, which is angle A. Okay, now, does anybody notice anything about what we just wrote down? What observations can you make? Hank? Good. The side, AB, does not have the angle that's small with it, right? It's away from it, isn't it? Okay. Angle C is not included in AB. Side AB does not make angle C, right? What's that name? What's the word that we use to talk about that, to describe the relationship between this side and this angle? Starts with an O. We've been using it all year. Starts with an O. We used it when we talked about parallel lines cut by a transversal. And we said things that were not adjacent, but what's the other word of opposite? Yes. Okay. These two are opposite each other. Side AB is opposite angle C. Okay. And AC is as far away from angle B as it can possibly be and still be in the same triangle. Make sense? Okay. They're opposite each other. Okay. So here's where your notes sheet comes in handy. Okay. And this is going to be a crazy name, it just kind of makes common sense, right? If one side of a triangle is longer than another side, then the angle opposite that longer side has to be larger than the angle opposite the smaller side. Bigger angle makes bigger opening, right? To bridge that opening, we need a bigger side. Does that make sense? Otherwise, they don't close up. Okay? And if one angle of a triangle is larger than another angle, then the side opposite the larger angle has to be longer or bigger, cover more distance than the one that's opposite the smaller angle. Make sense? Okay, kind of common sense, isn't it? Okay, ladies, let's put our phones away, please. Absolutely. Smallest angle, smallest side, medium angle, medium side, largest angle, largest side. Make sense? All right, so here's the kind of problem that you're going to be asked to do. Okay, they'll give you a triangle ABC, and they'll give you the three measures of the sides. And they will ask you to list the angles from smallest to largest. Okay, we want to list the angles from the smallest to the largest. Jace, what is our smallest angle going to be? Very good. The smallest side was 11. The angle opposite that 11 is angle A. Okay? And Jenny, what's going to be our middle sized angle? Absolutely, because our middle sized side was 12. The angle opposite the 12 is angle B. And finally, Eric, what's our third angle going to be? The largest angle. Yep. BA is the longest side, so what angle is opposite it? Single letter. Just angle C. Or you could, of course, give me the three-letter combos, right? But we don't need them when we only have a triangle. Each angle only has one angle coming off of it. Make sense? Okay. All right. So now we want to do the opposite. We have some angle measures, and we want to list the sides from shortest to longest. What's the first thing we're going to have to do, Mary? Not the sides, but the other angle, what angle C is equal to. Absolutely. So how are we going to do that? Very good. 61 and 59. 120. So 180 minus 120 is 60. Now that we have all three angles, we can make a comparison. Okay, so we check for the smallest angle. And Hong, what's the smallest side? Let him answer. BC, thank you. 59 was the smallest angle, so BC, the distance between B and C, will be the shortest distance. Okay? Then, what's coming next, Austin? CA. CA, opposite my next biggest side. So 59 was smallest, right? Medium size angle is 60. Which side is opposite? BA. Or if you said BC, that would be okay. I'm sorry, AB, that would be okay as well. Okay. And finally, Adam, what's our third side? CA. Not hard, right? For some reason, the writer of this textbook likes to give us the hard stuff at the beginning and the easy stuff at the end, right? So I want to make sure we understand this. Who has questions on this one? Okay. All right, next one. So now we want to talk about the triangle inequality theorem. Okay? And it looks kind of weird. So what I'm going to do is walk around with some pipe cleaners. And then we'll be back in just a moment. Just one. Okay? All right. So based on our theorem then, all we're concerned about is our two smallest sides and whether they are larger than the sum of them is larger than the third one. So is this going to form a triangle? No. Or yes. Okay, yes. So why? So 4 plus 9 is 13, right? And 13 is bigger than 10. So I need to see this much work, not just a yes or no answer. That's a guess. This one tells me you've done some addition. Okay? How about 8, 9, and 18? This is a no. Why? Good. So 17 is less than 18. You could say that. Or you could say 17 is not greater than 18. Either one gives me a no answer. Okay? And the last one, yes or no? So support it. Why? It equals 12 equals 12. That does not make a triangle. Okay? All right, here we go. Next one. So now we have to figure out what are the possible sides. Okay? A triangle has one side that has a length of 14 and another side that has a length of 9. Okay? So we've got something that's 14 in length and another one that is 9. So what do you think? What are our possibilities? Okay? Minimum it could be, if it was a whole number, would be 6, right? But what about 5.5 or 5.2? Okay, so 5 won't work, right? Why won't 5 work? Good, that would equal 14 minus 9, okay? So 5 is not an option, so it has to be bigger than 5, okay? It needs to be bigger than 5, okay? So then, what's the other possibility? How large could it be? Could our third side be 10? Could be 12, right? Uh-huh. Could, but what happens if this is 50? Okay, smaller than 50. Okay, max could be not 13, but so can 12 work? 9 and 12 is 21. Is 21 going to be bigger than 14? Okay. What about 30? Too much, isn't it? Because 30 is bigger than 14 plus 9 together, right? So 20. What about 22? What about 22.95? Okay. 22.99999, right? So has to be smaller than 23, but it can't be equal to it, right? So we don't want to put a little equal sign beneath it. We just want to have a smaller than, right? So x has to be between 23 and 5. Can't be 5, but could it be 5.1? Okay. So what did we do? How do we figure this out easily without having to try random numbers? What can we do with these two numbers to get 5? Subtract. So if we take 14 minus 9, that's the smallest it can be. Okay? What do we have to do with these two numbers to get 23? We added them. So if we take 14 plus 9, that's the max it could be. And then we make sure that we don't let them be equal. Okay? So we don't want an equal symbol. So if we did 23, so let's say that it was a number like, well, question again, I'm sorry. So 23 and 5 minus, or 23 minus 5 would get you what? 18? Not sure. There's a range of 18 numbers that would work. Does that make sense? Plus all the decimals in between. Okay? So it tells you how many possibilities you have with those. Okay? Make sense? Okay, do we need to see another example? Yeah, this one written down. Okay. All right, now we're going to talk about the Hinge theorem. Okay? And they like to show a gate or a door when they're talking about the Hinge theorem. I kind of like to talk about staplers. Okay? I have two staplers here, right? They're identical staplers. Okay? But they have a tiny little gap. And that gap is small enough to try to keep us from putting our fingers in there, right? When we're little, we can potentially staple our finger, but it's not very large of a gap. Okay? So a stapler is nothing more than two pieces of metal with some special mechanisms, right? And a hinge. Okay? And we can open that hinge up to be able to staple things to a bulletin board. Okay? So because they're identical, my sides, my top side is equal to my top side, my bottom side is equal to my bottom side, right? The only thing that's different is my hinge, my angle. Okay? So when I open one of them up wider, the angle became larger. What happened to the distance between the stapling mechanisms? It became greater as well. Okay? So if you have two sides congruent to two pairs of sides, and you open one angle up, what's that going to be due to the third side? Make it larger. Exactly. Same thing with the door. We open the door wide, we can get lots of people through. We open the door just a little bit, we can get very few people through. Okay? Make sense? Okay, so it's hard to see it. I don't know why. You can kind of see the gate kind of doubles over here. So this is the end of the opening. And so notice that even though we have the same width here and the gate's the same length, it hasn't changed, but the opening has. So here it was relatively closed. You only had this much opening. But then my angle got bigger, and now we've got a bigger gap. And then my angle got really large, became an obtuse angle, and now we've got a huge gap. We can't see it because it's blocked by the gate. Okay? Make sense? Okay, so here we go. So now we can ask you that if segment AB is congruent to segment DC, and segment BC is congruent to segment EF, so we've got two staplers, right, with congruent sides, right? But one of them had a bigger opening to fill than the other one. Okay? Based on this, how does the measure of angle B compare to the measure of angle E? How does this angle compare to this angle? Which one's bigger? B. So we want Pac-Man's mouth or the alligator's mouth, whoever's greedy, right, to open to angle B. Angle B is greater than the measure of angle E. Make sense? Okay. Next one. Okay, we can go the opposite way. We can say, guess what? I've given you two hinges, the two angle measures, right? And how does the distance between A and C compare to the distance between D and C? How does this guy compare to this guy? AC has to be larger, right? Just a little bit larger. So we want the alligator's mouth to open to the AC. AC is greater than DC. Questions on this one? All right. Okay, last one. Okay. What can you conclude about the measures of angles A and Q in this figure? Angle A is smaller than angle Q. Less than, left hand, looks like an L, right? Less than. Okay? Make sense? All right. Assignment's a worksheet.